So what do you do if you suspect hearing loss? That is the first question, right? What do you do if you suspect hearing loss? The first test is going to be your Rinnes or Rines Test. I don't know how you pronounce it, but the Rines Test, right? And this is a test where you're testing for either air conduction or bone conduction, alright? So the first thing you want to know is if there's air conduction or bone conduction. Now, normally, air conduction has to be greater than bone conduction in both ears, right? So you want air conduction to be greater than bone conduction in both ears. So this is normal. Abnormal is if bone conduction is greater than air conduction. Now, when you do your Rines test and you see that the test is normal, the initial test is normal, you have two possibilities. When you do your Rinnes test and you see that it's abnormal, you have two possibilities. Air conduction is greater than bone conduction, as we have right here, right? That means it's normal, and it can either be normal with the Weber's test, or we could find out they have sensorineural hearing loss, and we're going to get into that in 2 seconds, okay? Also, if bone conduction is greater than air conduction, like right here, which we already established is abnormal, right? We have two options. It's either we're going to end up having on the Weber's test conductive hearing loss, or it could even be worse and we could have mixed hearing loss. So I'll explain what that means in 2 seconds. So for the Rines test, it's very straightforward, so I feel like I didn't have to draw it, right? You have the tuning fork, you're either placing it in front of your ear or you're putting it to the bone. In front of the ear is air, putting it to the bone is bone. You want the air to sound louder than the bone. That's all it is, right? You want air to sound louder than bone. And if air doesn't sound louder than bone, then it's abnormal. Alright, so let's move forward. We're going to come back to this table soon. So normally we already established, right? So now we're talking about the Weber's test. And this test over here, right, is when you take the tuning fork and place it right in the middle of their head. Just like the guy over here, right? Right in the middle of the head. Now, normally, like the guy looks, he's happy. Normally, it should lateralize to both ears, right? Now, I want you to envision generator, right? So this is the schematic I actually made for you to always remember this. And now this is how you're going to remember this. This right here is the generator. And the generator is pretty much the driving force, right? It pushes whatever it pushes, electricity, fluid. Here we're talking fluid, okay? So the generator is the pusher of the fluid. This is the conduction pathway. What do I mean by conduction pathway? You need pipes, right? You need pipes, you need wires. For electricity to travel, for water to travel, you need a conduction pathway. That's what the conduction pathway is. And here are the ears. Now, you have to think of the generator as the CNS, right? The brain, right? Conduction pathway, or it's like your nerves traveling through your brain, right? The impulses traveling and then hitting the ears, and we hear, right? Right there, we're listening. And like, picture this right here moving, the water moving, and as it's moving, it's making noise in both ears, right? That is how the Weber's test is. Both ears, always, you hear noise. So sounds are made in both ears with Weber. So now, we know the normal, let's go to the abnormal. The abnormal, the first one we're going to talk about is what if the actual generator is destroyed, right? What if the generator that we also call the CNS is destroyed, what is going to happen? That's this. This is B, right? A was normal. B is when the generator, right, the CNS is destroyed. What's going to end up happening here is that the impulses, right, the fluid, the electricity, whatever you want to like picture this as, right, is now flowing to only one side. So you have to picture it. This, if we're saying that this is the right, and this is the left, right? Pretty much what I'm trying to say is that if we have a damage to the left, we're not going to hear anything in the left ear. You're not going to hear anything in the left ear if your left brain is damaged, okay? And that's known as sensorineural hearing loss. When you hear people saying sensorineural hearing loss, that's what it means. It means that the nerve is destroyed, right? The nervous system is destroyed. The generator is destroyed. So if it's destroyed on the left side, it is going to be on the left side that they're not going to be able to hear anything, okay? Just like the picture over here. Look at the picture. You see the guy? This is his left side. His left side is damaged. You can see it in the brain. So guess what? He does not hear anything when the Weber is done. So it lateralizes, like pretty much the sound goes to the side that you're finding. You can hear on that side. Because of guess what? The generator on that side is still working. That's how you should remember it. The generator on that side is working. That is sensorineural hearing loss. So it's ipsilateral generator. If you remember that, you'll be good to go. And the final one is when there's an actual problem with the conduction system, right? I told you these were the pipes. Now imagine, right, downstream of the pipe, we have a blockage right here, like you can see right here. Look at the blockage. If we have a blockage there, what's going to end up happening over time is there's going to be a buildup in pressure on this side, right? And remember, these are ears. So if there's a buildup in pressure on this side, then surely ear 2 is going to be hearing a lot more noise. Ear 2 is going to be hearing a lot more noise. You see, the generator is good, right? The ears are good, but it's the actual conduction apparatus that has a problem, right? And you see, in this actual situation, you're hearing the noise where there's a problem, as opposed to here, where you're hearing the noise when there's no problem, because here it has to do with the brain, right? And here it has to do with the actual conduction system, right? Like this is the brain, your nervous system, your nerves or whatever, and this is the actual conduction. Like this is what conducts it to the ears. That's what's messed up, right? And there's a lot of reasons why, but I'm just explaining the actual test right now. And then just to reinforce what I'm saying, look at the guy over here, right? You can see that he has problems on this side, on the left side. And guess what? He's hearing the noise louder on the left side because the pressure is higher. Remember, increased pressure. Why is there increased pressure? Because there's a blockage. Don't forget. That's why. So that's pretty much it. Like, if you can remember that for the Weber's test, you're golden. So now let's just review everything finally, right? Just by looking at this table over here, right? Looking at the table over here, normal, we already said, right? For the Rines test is air conduction over bone conduction, right? And for the Weber's test, it's going to lateralize to both ears. Correct? Yes, we said that. Lateralize to both ears, air greater than bone, right? So now, what did we say about the generator? The generator is the brain, right? It's the CNS. It's your nervous system. It's your central nervous system. And if that's destroyed, what's going to happen? Let's look back. Just to reinforce it, right? The same side that is damaged is the same side that's not going to hear anything on the Weber's test. But the Rines test is going to be normal. See? Rines test is normal. The Weber's test, no noise in the bad ear. And then we have conduction hearing loss, right? Conductive hearing loss. What happens there? Rines test is abnormal because bone is greater than ear conduction. And of course, there's a loud noise due to the pressure, like we said over here, right? So there's a loud noise due to the pressure, and that causes you to hear a louder noise on the side, on the exact same side. And finally, the final one that I would like to explain a little better is mixed, right? So with mixed, you have an abnormal Rines test, and you also have a positive Weber's test in the opposite ear. So a good example of that would be like somebody who has like positive Rines test, which is bone conduction on the left ear, but then on the right ear they have Weber's test. So the noise is actually lateralizing to the other ear. That right there is a mixed. See, of the opposite ear. If I have Rines test on the left and then I have Weber's test on the right, automatically that's the only possibility, right? If you really think about it, right? You see right, left, mixed. Right, conduction. Normal, right or left, generator. That's pretty much what it is. That's it for today. I hope you guys actually enjoyed this video. I'm going to be putting out more videos, so I really appreciate it if you could like my videos, subscribe, and share. And until next time, have a good one. Bye.